Hi out there again. So today another nice repair video. So I have a nice ICOM IC-7000 for you, and well, the owner reported that something is wrong with UHF receive, and yeah, all the other passes are okay as far as he told me. So he said that maybe a strong signal came into the antenna jack due to the fact that he was transmitting with another radio very close to this radio. And yeah, of course the radio on UHF was switched on, and so the full power of the other radio where he was transmitting with came completely into this antenna jack. So that might damage the front end of the UHF channel or UHF pass, whatever you like. And yeah, therefore let us check if we find exactly the same symptom, and well, if that is the fact, then let's see if we can repair this really nice radio. Well, and of course first what we are checking is the receive, and I have dialed in VHF, and I'm already injecting a signal, and you see we have here a nice S9 indication, and when I switch the preamp, you see that the S-meter indication increase, so that is obviously working. And yeah, on our test set we will see the figures. Well, and here is what we have. So the generator is set to the 2 meter band, and we are feeding in with minus 73 dBm, and well, we have here a deviation of 2 kilohertz, and well, the feedback is now approximately 400 millivolt, and we have a SINAT of 34 dB. So that all looks quite nice. Yeah, and here is the tone, you can hear it, and you see a nice sign here on the scope. So it looks like that on 2 meter on the VHF band the radio is working just fine. Okay, so then let's switch to our 70 centimeter to UHF. Okay, radio now in UHF, and I'm feeding in at least the same signal level, so that is exactly the same what I did on VHF. And well, what you can see down here, the S-meter indication is it is not only S1, so this is already a very weak indication, and yeah, with preamp you might see it is maybe S1, but it is very weak. And let me switch the speaker. Yeah, don't know if you can hear the speaker, so almost nothing, and that is with preamp on, preamp off, and there is only a bit static on my lap monitor down here, so only static, so yeah, at least nothing. Yeah, as I already said, so the signal generator level is on the same setting as we had it with the VHF, and well, you see the feedback is producing 13-15 millivolt, and that is almost nothing, and you do not see a sign here on the scope. So when I engage the preamplifier, now you see we have a bit more feedback level from the radio, but anyway, so that is nothing. We have the same volume setting on the radio, so no differences to VHF. And well, yeah, let me switch it to SINET. SINET is almost not readable, so let me switch off the preamp. Now nothing, absolutely nothing. So the only thing we can do is we can of course increase our level and see if here we are. So now we have a little signal, but you can hear it is still very noisy, and you see our SINET is almost nothing. Let me see what, yeah, okay, so we have now really feedback from the radio. So this is 500 millivolt, and that should really produce a nice and stable signal. So that means radio is really dead on receive. So with really a big input level, you can barely hear that there is a tone, but it is more noisy than anything else. And yeah, that means that obviously something is wrong in the front end, in the UHF front end. And well, the reason why I did the VHF test before the UHF test is to see what the behavior is on VHF, because UHF and VHF are using in some stages the same signal path. So now we know the problem must be somewhere in the front end, because when the signal is leaving the front end, it is exactly the same signal path which is VHF using as well. And you see with this strong input level, you can see almost S3. So yeah, that is a clear indication that we have a serious problem in our UHF front end. And well, so let's crack it open and see where the problem is. Well, but before we start poking around, let's have a look into the block diagram. And yeah, that is too small. I can't see it really, so let's enlarge it a little bit just to see the relevant area. So maybe a bit more, like so. And now you already see the relevant area. So here we have our input, our antenna input. So of course 2 meter and 70 centimeter together. So I think you was not able to see it. So here is the antenna, okay, and then you know we have directly a split for our UHF and VHF signal, simply because here is a low pass filter and here a high pass filter, and you clearly see that we have from here two different signal passes. So this one here is of course the UHF signal pass, and this here is of course the VHF signal pass. And when we follow along this signal pass, we easily see that finally at this point up here both signals are combined again. So that means this pass here already is 430 or 144 either way. So that means, as I told you before, that means because we have already checked out our VHF pass and it is working perfect, that means that all behind this here is working, and the only thing which is obviously not working is here this front end. And you see, if I go a little bit closer, so we have two preamps here in between, and maybe that one of this both preamps may be toasted, so we don't know yet, but that is most likely the cause, or it is a switching voltage or something like that. So, well, I think now we know already a bit more, and we know, and that is typical for ICOM, the preamplifier for VHF and UHF is already on the power amplifier board. So it is not on the main board as you might expect it. No, it is already on the power amplifier board. So now we need to open the radio that we have access to the power amplifier board, and then we need to find this signal pass, and then we can start and poking around. Okay, but now let's take it apart, and we should get access from the button side. So there should be our power amplifier, and that is what we wanna check out right now. Okay, so all screws should be out right now, and ta-da, we are in. Okay, so here is our yeah, can you see it? I hope. Yeah, this is our power amplifier board, and as well our filter board. So this part should be the low pass filter circuit, and this is here our HF amplifier, power amplifier, and then we have yeah, around here our yeah, that must be the UHF, and that's a VHF No, it is different. So this is a UHF power amplifier, and this here is a VHF power amplifier. Don't know if you really are able to see it. Might be a little bit difficult, but anyway. So, but you know, this is not of any interest for the moment in time. Now it is more important to find the receive signal path through our power amplifier board, and therefore I have to watch into the board layout to find the signal path through this board. Okay, so this is now the portion we are interested in. So this is the UHF signal path, as already said, and yeah, we have two pre-amplifiers in here. So this one is a pre-amplifier which can be engaged from the outside, so that is our switch where we can engage or disengage the pre-amplifier, as already known. And well, this is the normal amplifier which has to bring up the level in general. So, well, first of all, we want to have a look into this guy here, and then here. Okay, and that is now the circuitry. So you can see here this little dual gate FET, and well, here we can engage the pre-amplification by putting here some power to it, and then it will have a higher gain, and this will lead then into this amplifier. And well, the plan right now is to feed in the signal right from our antenna jack, and we have recognized before that as long the input level is high enough, we can hear a little bit. So what I'm interested in is, if we engage our pre-amplifier, can we then recognize a significant change? Because if so, then we can be, I don't know, let me say 80% sure that this guy here is working. And well, what I'm also interested in is, are the DC voltages available, first at the dual gate FET, and secondly, is the DC voltage available at the IC-7000. And the voltage which should be available is approximately 6 or 6.5 volt, which is supplied through here, and then we have supply here at the dual gate FET, and as well we have our power, our supply voltage here to pin 6, and both should be approximately 6 or 6.5 volt. So that will be the first step. Well, and to locate it on our PCB, I have here the layout, and I've already marked this both components. So this is the pre amplifier, which we can additionally engage from outside with our push button, and this here is the second integrated circuit in the signal path, and this guy should at least increase our gain of about approximately 20 dB. And well, when I take this here away, so then we can see the second integrated circuit in the chain, and yeah, here you can see the information that the power gain is, oops, can you really see it? Sorry for that. Yeah, here you can see it. So the power gain is 20.5 dB, and well, that is really a high amplification, and that should be easily to check. Okay, so what we gonna check first is the preamplifier. So I'm just injecting a very high level which should easily show more than S9, and you see there is no indication on our display. So I now gonna activate our preamplifier like so. And what you see and hear is that we get an S meter indication. It is I don't know, maybe S3 or so, and without the activated preamplifier we see nothing. So that definitely means that obviously our first where do I have the plan? So that means obviously that our first MOSFET seems to be working, and maybe this guy here is doing something odd. So that is what we need to check next. Yeah, here on the board, this down here is our dual gate FET transistor, and a little bit more down here. Oh, does it work or not? What is about focus? Okay, and here, this little component down here is our inline amplifier, the IC-471, which should be able to amplify with 20 dB. So we have seen when we engage this guy here, I can do it once again. It is here. So we clearly can hear a signal, and well, secondly, or subsequently, this guy here could be the problem. So let us check it a little bit more in depth. Okay, so as I said, I'm now interested in the DC voltage, and first of all I want to see the supply voltage of our dual FET, which should be here, and so what we can read is 6.7 volt DC, so that is good, so that is a good value. And secondly, I want to check the second gate, where we can engage or disengage our preamplification, and I am now at the gate 2, and yeah, what you clearly see, I'm able to switch on the preamplifier by the front panel button, and you see the DC voltage is going up, and you clearly hear that the signal gets amplified you can recognize that this guy is obviously working. So that is clear. So next I'm interested in our IC-471, and first of all I'm interested in the DC voltage, which should be available at pin 6, and pin 6 is this guy, and so it is only 4.5 volt, and that is definitely not okay. So I expect 6.5, nearly the same voltage we have seen at the dual gate MOSFET. So I believe that this component is drawing some current, and that could be the first indication that this guy here is dead. Well, as we have seen it before, this amplifier only gets 4.5 volt, and as I said, that might be an indication that something is wrong here, so that there is somehow something is drawing power, and therefore I just interested what could be the voltage before this R470, because if the voltage here at the supply side is also approximately 6.7 volt, which we have seen at the dual gate FET, and at the other side, so that means the supply to the IC is 4.5 volt, then that is really then an indication that something is wrong, because this IC is indicated in the data sheet with 6 volt. Let me double check. Yes, with 6 volt supply voltage. So the minimum what we should read at point 6 is 6 volt, and we read, as we have seen, 4.5. So now we're gonna check the voltage here at our resistor, and going here down to our board plan. So the R470 is this guy, and well, we will check on both sides, and if we have here on this side 6.57 volt, then this here becomes more and more into focus. Okay, so let's start our probing, and well, so now I'm on point or pin 6, which is our 4.5 volt, what we have seen before, and now I go to the other side of our resistor, what we have seen in the schematic, and Yeah, have a look. So there we have 6.8 volt, and that clearly indicates that there is a massive current flow, maybe through this component, or maybe a component which is around this IC. Okay, so the next we can do is injecting a signal at the input and at the output. So therefore let me again switch on the radio. Okay, so now it is on, and here is our input, and not really. And this is our output. And yeah, pin 1 is down here. So that is almost nothing. And here we have more or less a signal. I mean, so we have some adaptation problems because I have no 50 ohm here with my injecting needle, so therefore it sounds a little bit odd, but in any case you clearly see and hear, you more see it, that I have, when I go to the output, so this is the little output cup. I hope you can see it, this one here, and this is the output cup, and here is the input cup, and you see if I touch the input you do not hear nothing, but at the output there is finally a signal, and this is more or less clear that this guy down here has a problem. So yeah, we need to replace it, and well, when we summarize our findings, we know that this guy definitely is drawing too much current, which is an indication because the voltage is too low at the input, and we see when we inject a signal to the input there is almost nothing to hear, and when we inject it at the output then we hear the tone. Even it is so there are some reflections because it is not 50 ohm what I'm injecting with my injector, but that is not the issue. The issue is that we obviously have a problem with this guy, and well, so I would say I gonna order a new one, and well, maybe that there is something additionally, but that is always the same game. You never know if there is another component which is infected from this problem, and so you know, this is not clear until we have replaced this little guy down here. So I guess next is to really order a new part. So finally ICOM parts arrived. So it really has taken a while because our needed little IC was not available at the European Service Center of ICOM. So they need to send it from Japan as far as they told us, and well, but anyway, it is here, and our little IC should be in here as well. And yeah, here it is, and I don't know if you can see it, so let me go a little closer, and then you get an impression how really small it is. So that is our little amplifier IC, which we need in the front end of our UHF stage. So yeah, let's see what we can do to replace it. Okay, we need to get off the old IC from the PCB, and as you have seen before, this component is really tiny, and therefore we need to work with our magnifier, and we need to work with the hot air gun to get this little component off. And that is really a little bit critical, because we have a double-sided PCB, and when I go and heat up this area, we also heat up the opposite area from this PCB, and that makes it more than critical, because while I'm heating up this area, I also heat up the other side, and that means little components could fall off from the other side without I will really recognize it directly. So, you know, now we really need to be careful, and please apologize, but I'm really not able to do this job down here through the camera. Yeah, just to remember, this is our faulty part which we need to replace, and this here is our replacement part, and you may already see watching the back how really tiny it is. So let's try and do our best to get it off, and yeah, I will be back. Alright, component is off. Here you see the little IC, and well, it came off with some difficulties because it is glued. It was glued as well, so you may see or not. Yeah, let me put this IC by side. Okay, I've repositioned the camera a little bit for you, and you may see down here. So these are now the pads, and you see here the red dots, so that is the glue, and that makes it a little bit difficult to get the IC off, but now we have got it away, and I will then clean the pads and will replace the new IC into this place. Okay, so I have now cleaned the pads. So this here is the area for our new IC. So pads and board is clean, and I have taken off a little capacitor down here, because then I have a better access to the IC to solder it in, because I don't want to do it with the hot air gun, as we still have the same problem on the other side of this PCB. There are also SMD parts, and you know that is always critical. So I decided to remove this little capacitor, and the pads are cleaned as well. The glue is removed, and now we will be able to place our new IC down here and solder it in. Yeah, and again, sorry, you know, this is really such a little tiny part. I'm really not able to do it here through the camera, so that is really impossible. If yeah, I want to do a good job on this radio, so sorry for that. Alright, so the new part is in, so you see down here the new IC, and I have installed back, of course, the little capacitor, and well, so far everything is fine, and yeah, next will be to check the circuit if we have now again our amplification. Okay, so we are ready for test. Yeah, I have already prepared the radio and as well our communication tester, so everything has been set already to what we need. So next will be to connect the radio to our power supply, and yeah, let's do it this way. So power supply is set to 13.7 volt. Okay, so connections are all done so far, and yeah, so let us switch on the radio and see if it works. Okay, so far, so let us switch it on, and it is initializing. Whoop. Yeah, let's switch off the speaker. So the radio is on 438.750, and yeah, for the moment in time the generator is off, as you can see here. So so this is clearly switched off. So now let us inject minus 80 dBm, so minus 80 dBm, and let's see what will happening to our radio. Hey, and oh, what a nice reaction. So let me switch off our speaker so that we can better see what's happening. So we have back a signal, so you can see here what we have. So our radio is already receiving on the dialed in frequency, so that means our signal path, our UHF signal path is back to life, and yeah, we are on minus 80. So let us have a look on our S meter, what we can find there. Yeah, and I have repositioned the camera for you, and yeah, what you can see here now, we have back our S meter indication. So a speaker, yeah, you can clearly hear the tone, and it is yeah, loud and clear. So the receiver is really back to life, and you can also see a very nice signal on our tester. Yeah, you can see it here. So that is the signal, right? So that is the feedback, and what you can see is that we have really a very nice sign. So you see the IC what we have swapped was really the cause why the radio didn't receive, but yeah, now it is back to life. Okay, finally what we have to do is to check the receiver for performance, and we have here this little table, and we can see here on the 70 centimeter band on FM mode we should be able to reach 12 dB SINET with 0.18 microvolt. So that is the indicated level, and we get here the information that the preamp has to be switched on. So what I'm gonna do right now, I set the generator to 0.18 microvolt, and we want to see if we have our 12 dB SINET. Okay, and we have here our indication. So the generator is set to 0.18 microvolt, so that is 180 nanovolt, and of course the signal is noisy, so you can hear that. And well, but what you can see as well, so that is our SINET value, and it is jumping, of course, due to the immense noise we have with the signal. But in any case, so I would say in average we are around 12-13 dB SINET. So yeah, we can finally say that the performance is okay on receive, and that means everything is fine. And of course the preamp is switched on, and with such a low level you do not see any S-meter indication, so that is clear. Well, but basically, as I already said, the radio is back to life, and yeah, we are finally at the end of our story and of our repair, of course. And if you like this video, please give a big thumb up for this video, and yeah, catch you all next time. Bye.